Video lesson 10.8, volume of a sphere. So in this one here, we're going to be talking about the volume of a sphere, which is just a three-dimensional circle. So if I take here a cross-section of any direction of this sphere, I'm going to have just a circle from there. So it doesn't matter where you do it, you'll have a circle for your cross-section. The formula, as you can see right here, is V is equal to 4/3 pi r cubed. So this formula obviously looks a little different than most of the ones that we've been using. Probably the most important thing to notice is, yes, it does have 4/3 in the front, which is kind of a helpful indicator of remembering which one this goes to. But most importantly is the fact that you have cubed with the r. It's the only one. Everybody else that we've been dealing with has had, some of them had squared and other things, but this is the only one so far that we've had with a cubed exponent. So keep that in mind while we use this. So again, just as we go through these volume questions, again, they're all very similar, just utilizing different formulas. So for this first example, we want to find this volume of the sphere. It's telling us the diameter is 42, so that would be the entire way across the sphere. As we know, we only want the radius, so we only want halfway here. So I'm going to cut that in half. So I'm going to take this part here, because the diameter here is 42. So r is going to be 42 divided by 2, which is 21. So that's my radius. So now I'm just going to plug that into the formula. So V is equal to 4/3 pi, and we're going to put 21. And we're going to cube that. So when we do this, it's all about just plugging it in. Be careful. Again, with the 4/3 part, I kind of recommend doing everything else out first, and then being careful when you plug it in the calculator. And now I can multiply this together. So when I do that, if I plug this in, 9261, we're going to multiply that by 4/3. Now again, if you're I recommend using the fraction bar to keep the 4/3. This way you don't have to worry about parentheses or anything, right? Which is there. So I get 1, so that's 12,348 pi, right? And it does say in terms of pi, so we are actually done there. Just, oops, don't let me forget my units, which is inches cubed. Just one thing on the calculator to note: if you don't use the fraction bar, so if I was just doing it as 4 divided by 3, make sure you put that in parentheses, otherwise you could have a problem. So if you're going to do that, oops, what did I do? Then you got to make sure that it works properly as well. Without that parentheses, it could cause problems depending on what you're doing in front of the situation. All right, example number 2. Here's one of those examples where they give us the volume. And they ask us to find one of the parts. So in this one specifically, the diameter. So V is equal to 4/3 pi r cubed. So now again, we're told what the V is, right? That's this part here. So 288 equals 4/3 pi r cubed. So my goal here is to find r, because in this case the diameter. So diameter is just going to be 2 times r. So if I find the r value, I can multiply that by 2 and then have my diameter. So when we're solving this one here, again, we just want to, this is all multiplication, so normally just divide by what's in front here. But because it's 4/3, we don't want to divide by a fraction. So I would recommend doing this in parts. Take this fraction, I'm going to multiply by the reciprocal. So 3/4, same thing over here, 3/4. Right, that'll allow this to cancel out. I'll be left with just pi r cubed on the right, and then 288 times 3/4, that's 216. And now I can divide by pi. Right, now I can divide each side by pi. That will get me just r cubed is equal to 216 divided by pi. Now I would, again, before plugging in the calculator, I would simplify this a little bit more. I would say I got to get rid of the cube part. So opposite of squaring something is a square root. So the opposite of cubing something is a cubed root. So again, take the radical sign, put a little 3 in the check mark there, like so. That indicates that we're doing cubed root. So that gives me, let's do it off the side here, r equals the cubed root of 216 over pi. And now I go into my calculator and plug that in. So let's see what we get with that here. So let's clear that out. We've got 216 divided by pi. And then we want to take the cube root. So again, math option 4 is my cubed root portion. So math option 4. And then I'm going to take this answer and I'm going to plug in there. So again, without having to type the whole thing in, I can shortcut that second negative sign. That's ANS. That's where it says answer. So the answer above. Take that, hit enter. So I get an answer of 4.96 blah 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 blah. So r is equal to 4. What did you say? 097, and so on and so forth. Again, we don't want r, we want the diameter. So now I got to take this whole thing as we did up here, right? So d is going to equal 2 times all of this. And I'm going to use the whole number. Even though I'm not writing the whole number down here, I am going to use the whole number in the calculator. So I'm just going to simply take that and hit times 2. So I get 8.194. And the question said to the nearest tenth. So D is going to be approximately 8.2. And this was inches. So there we go. So again, notice the important things is that, took the time to do each part individually. Technically, from a mathematical perspective, could I have gotten rid of the 4/3 and the pi all in one shot? Yes. I do recommend, though, doing it in pieces. It just makes it a little bit easier. And again, I don't want to have to carry around the decimal. So again, I simplify the process at the very end, and then utilize the entire decimal that's inside the calculator. So do take a caution when you're doing that. You want to make sure you're taking the time that you plug the parts in or copy the information down correctly. All right, example number 3. Here, they just like the other types of questions. Sometimes they give us the information in a alternate form. So they give us the circumference of the figure, and they ask for the sphere. So again, in order for us to do this, we still need the radius. We still need to know. I'll do it this way, right? So still need to know what the radius is. Need r. So we got to work backwards to get that. So got to think back to our circumference formula. So the circumference formula was C is equal to pi times d, or C is equal to 2 pi r. So in this case, I'm going to go with the 2 pi r because we want r as our answer. So I'm going to plug in my 95 here for C and solve for r. So again, I'm going to divide here because all multiplications by 2 pi. Divide both sides by 2 pi. That eliminates everything on the right side except for r. And again, I'm going to leave this as 95 over 2 pi because I know that's going to get me a decimal. And I don't want to have to carry that whole thing around. So I'm going to wait to plug that in, and I'm going to plug it into my formula here. So V is equal to 4/3 pi r cubed. So in this case, that's 4/3 pi times the answer we just got, which is 95 over 2 pi. And now I can plug this into my calculator. Again, I want to show the formula. I want to show what I've plugged in, then use the calculator to actually solve the answer. So let's take this here. Let's clear this out. We've got, clear that out. So we've got 95 divided by, again, if I'm doing it this way, I got to put the 2 pi in parentheses, right? Otherwise it will be an error, or you could do it as a fraction bar, which probably a little bit safer. All right, so that's my radius there. I'm going to multiply that by 4/3. All right, right? That's 20.159, right? And I still need to multiply by the pi. So I'm going to say one more step, multiply by pi. Hit enter. So that's the decimal that I get, which does not. Oh, you know what I realized? What we forgot to do? We didn't cube our radius. So let's go back and adjust that. So you know what? This time I'll do it with the fraction bar here. So just to show you how it works. So we're going to take the fraction bar method, right? So we got 95 over 2 pi, right? That answer, right? We're going to cube that. Take that whole thing, raise to the third power, and then we're going to multiply by 4/3. And then we're going to multiply that by pi. That looks a lot more realistic. All right, so let's take that number. We've got 14478.60988 blah 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 blah. Oh no, sorry. It's 3749. And we want to round that to nearest centimeter. So it's approximately 14478 cubic units. So we got 14,478 cubic centimeters for this specific circle. All right, last two questions here. A little bit more involved. These are the kinds of questions where they've taken it to a new level. Kind of asked you to kind of work on information based on what they've told you, but to find like other parts or other things. So in this first one, they're asking you to find what percent of the cube. So percent is just simply, part over whole, times 100. So we want to find out what that percentage is. So really, if I'm doing this figure here, I just need to do it in two parts. First, I need to find the volume of the cube, and then I got to find the volume of the sphere. Right, so let's do the cube first. That's just side cubed. So that's going to be 8 cubed. And 8 cubed is, that's 512. The sphere, which we know just is 4/3 pi r cubed. So this is going to be 4/3 pi. My r here is, again, if it's telling you that the largest possible sphere, meaning that the sphere fits inside the box, like the top and the bottom touch, the sides touch. So this would be the same thing as this. So therefore, I want half of that. So I want half of this. So my radius is going to be 4 here for that. So let's plug this in here. So 4/3 pi, this is 64. All right, and then I can now plug this into the calculator. So let's do that. So we got 64 times 4/3. All right, 256 over 3, and we're going to multiply that by pi, which gets us this decimal number here. So that's 268.0825, blah, blah, blah. And again, we want a percentage now. So the percent is going to equal, again, part over whole. So in this case, our part is our sphere. I'm going to divide that by the whole thing, which was the cube. So if we plug that in here, so we got my answer. I want to just divide that by 512. That's going to get us this decimal, which is 0.52398, blah, blah, blah. And again, we want a percentage, so all I'm going to do is scoop twice or multiply by 100, same thing. So it's going to give me approximately, and we want nearest percent, so approximately 52% of this cube is filled by the sphere. So again, it's really nothing much more. then just finding the volumes, and then just an additional process to give the information the way they are requesting it. And again, in this case, it's as a percent. All right, number 5. And then here's where this is building to questions that are going to be a little bit more, common, especially on like the regions, like you said, like a part 3 or a part 4 kind of a question, where they're more involved. They've got multiple steps, ask you to find multiple pieces, take your information and use it for something else. So that's what we're seeing here. So in this question here, we're asked to find the volume of the silo. So this silo is comprised of both a cylinder and a hemisphere. So a hemisphere is just half of a sphere. So we're going to find both things. So first one, let's do volume of the silo is going to equal, that'll be the volume of the hemisphere plus the volume of the cylinder. I'm just going to abbreviate so we keep our information there. All right, so let's do the hemisphere first. So volume of the hemisphere, right, is going to equal, that's just half of the volume of the cube. All right. If you can simplify that, you can just, it's all multiplication. So 1/2 of 4/3. A nicer version of that is just going to be 2/3 pi r cubed. So again, that's going to be true every single time. It's not bad to just memorize that formula, but worst case, you just simply write it out and multiply it. Not the end of the world. So we got 2/3 pi r. Again, this top is the same as the bottom, so my radius is 5. I'm going to plug that into the calculator. Again, because I'm doing more, I'm going to leave it in terms of pi right now. So I'm going to say here, let's do 5 cubed. Yeah, that's 5 cubed. All right, I'm going to multiply that by 4/3. Oops, I did 4/33 instead. So it's going to be 125 times, let's try that again, 4/3. And I want to multiply that by 2/3. Oops, sorry, actually, since I did 4/3, I would have to do a half again. But let's go back and do one, make that a little simpler. So 125 times 2/3 as we wanted, instead of having to do it as twice. 2/3. That makes more sense. So there we go. And then don't forget, we haven't done anything to pi yet, so pi is still there. So we've got 250 pi. So I'm going to leave it like this because I'm going to plug it in over here and wait and not have to carry around all my decimals and everything like that. So let's do that part first. Then the next part is we need the cylinder. I'm going to do that down here. All right. So that's just pi r squared times h. So this one we can just plug in. We've got 5 for our radius, 15 for our height. So if I plug those in, that's 25, and 25 times 15 is 375. So that's 375 pi. So now I can take that answer and plug it in. So that's what we're adding together. All right, so now I can go into the calculator, plug these numbers in, and give us a result for the entire volume. So let's do that now. So we plug that in. We get this decimal, and that would be to the nearest foot, so approximately 1,440 cubic feet. So that's going to be the volume of our silo for this first part. So like I said, individually do the parts, then just add them together from there. Now part B says, how many tons of corn can the silo hold if there are 2,000 pounds per ton? So we kind of have to go back to the original question here, because we got to remember that density is equal to mass over volume. We're asked to find here how many tons. That would be the mass. So I'm going to rewrite this formula as mass is equal to density times formula, so aka just cross multiplied. So from here, so if I have the density, all I have to do is multiply the volume that we just got. They gave us the density in the original question. And again, I know this is the density. Not only does it say it, but it's got the double units, pounds per cubic foot. So now I can plug that in here. So 16, again, this is, I'm going to write the units here because I want to show you guys something to help you realize. So pounds per cubic foot, and I'm going to be multiplying that by what we just found, which was the volume of 1,440 feet cubed. So again, remember, when you're multiplying this, when you actually multiply them out from here, this would be just straight multiplication. So the numbers would just simply be 16 times 1440, which gets me, what, 23,040. Right? Now, but look, the feet would cancel. I would just be left with pounds. We don't want pounds. We want tons. So I need to convert that. So just off to the side here, right? It told us that 1 ton was the same as 2,000 pounds. So I can make a proportion now and say how many tons would 23,040 be from there. So that allows me to kind of like, cross multiply and solve. But if you notice, it's just going to be this number divided by 2,000. So I can just simply shortcut that by just noticing or remembering or realizing that it's just a division process here. Again, if this is not something you remember, it's fine. Just make the proportion, cross multiply and solve. Not the end of the world. But here, if I just divide that out, that's going to get us, let's see what happens when that would be 23,040. We're going to divide that by 2,000. And we get 11.52. So that means it's 11.52 tons. They want to nearest tenth, actually, so it's approximately 11.5 tons. And there's my answer. So again, a lot more involved in this example, but that's exactly what they're going to kind of develop to. This is, like I said, this is realistically more of what you're going to see on like types of part 3 questions. And if it was a part 4, it'd probably be even something else involved, even more. But this is something that we definitely should be able to do. Do the parts and then utilize that information, to find something else. Again, conversions are a common thing. They like the density questions as well. So take a chance to just review the video, any questions, or go back and look over any problems you may have had. And don't forget to utilize the practice problems for more understanding.